All right, we're going to move on to topic 7.1, and we have just one topic left after this to complete Math 1108. So here we are starting at the beginning of our study of probability. Now, when we think of probability, you might ask, well, what are we thinking about? Well, it's the likelihood that an event would occur. But there's some mathematics involved in it. So let's take a look. We want to be able to calculate basic probability. To begin our discussion of probability, we need to define a few terms. So you want to write these up in your notes. First, a trial or probability experiment is any process that produces a random result, such as drawing a number from 1 to 10 out of a hat. This example easily illustrates the possible individual results called outcomes. For this example, all numbers from 1 to 10 are outcomes. So keywords here is a trial, that is the event that you're going to do. And then the outcomes would be what could possibly happen. And probability is sort of a ratio that you will select a trial, an item, out of the number of items that there are. So the number of items is listed here, 1 through 10. These are like little tickets, and there's a number on each one. They're in a hat. This makes up what is called the sample space for that experiment. So these little tickets, 1 to 10, are in a hat. You're going to randomly select one of those from the hat, and what's the probability that you're going to get a particular number? So, identifying the sample space for each of the following experiments, note that the outcomes in a sample space are listed between brackets, sort of like a set, and separated by commas. All right, so think of this one. What's your sample space for rolling a single die? And you might say, what is a die? Well, it's one of a set of dice. And as we look at it, how many sides does a die have? Well, since it's a cube, it's going to have 6 sides. And then there's a number on each one of the sides. And if it's weighted properly, when you shake it up, it's random. We think of an honest die as to which number will land on top. So your sample space then for a single die is 6. How about the birth order, gender, for 2 children in a single family? Well, remember there are 2 basic genders, male and female, and as you give birth to a child without knowing ahead of time, it could be male or female. So that's 2 possibilities. In a second birth, there are 2 possibilities, again. So that would give you 4 possibilities in your sample space. Let's look at the solutions. All right, we've gone over that for the die. So there are your 6 possibilities. Now, when you roll a set of dice, which is the plural, notice that your sample space is going to increase quite a bit. It gets to be 36 possibilities, but we'll go into that a little later. So your sample space for gender, again, is a boy and a girl. So, listing them, actually, you could have boy, 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 girl, girl, boy, girl, girl. Now, any of you who have taken biology, and I think we could add it this time here, you may recall that old little chart that they would make here. So you could have a possible boy, girl, boy, girl, and then you fill it in. There's your BB, BG, GB, GG. So the sample space for letter B is 4. Let's continue. All right, for your skill check number 1, identify the sample space for tossing 2 coins. Now, what's the possibility when you toss a coin? It could be heads or it could be tails. So it's going to be very much like boy, girl, girl, boy. And so if you have 2 coins, there will be 4 in your sample space. And there they are listed below. So we're going to look at the word trial now. A trial, or a probability experiment, is any process that produces a random result. Now, years ago, they talked of a coin that was, when it was minted, somehow ended up with 2 heads or 2 tails. So when you flip it, those coins, there is no choice. You're always going to get a heads, or if that's what it is, or you're always going to get a tails. So we bring in this concept of honest coins, random result. So they'll be mentioning that from time to time. Now, when you do a trial, you get an outcome. This is your results. Again, this is all part of vocabulary. And the sample space, once again, is the set of all possible outcomes. And pause as you need to take these notes down. So, we're going to start to develop a mathematical formula. An event E is the group or subset of outcomes. This is your desired results of the sample space. So here is the equation or the formula for classical probability. So P, in the sense, the probability of an event is equal to the number of possible outcomes in the event as to the number of outcomes in the sample space. So what you're looking for out of the number of items that could possibly happen. Now, some parameters for this is the event will always be a real number between 0 being it couldn't happen, and 1 that it always happens. So between these, that is what your inclusive probability would be. Now, we did talk about a deck of cards, but here they're going to go through it in much greater detail. The standard deck is 52 cards, and here is the layout of it. So in a deck of cards, there are 4 suits: diamonds, hearts, these are the red ones, clubs, and spades, these are the black cards. And then we start with an ace, and then go through 10 numbered cards, and then we have the 3 face cards in each suit. So we have done this before, and a nice review here. So we're going to do some calculating now using classical probability. That is the formula, tie it in the math, probability of an event is equal to the desired outcome over the sample space. This is your classical probability. What is the probability that the card you draw is going to be red? What is the probability that the card you draw is a diamond? What is the probability that the card you draw is a face card? What is the probability of drawing a red spade? So this goes through it, but let's look at it ourselves here too. So the probability of this event, how many red cards in a deck? Well, we said there were 26. How many cards in a deck? 52. So we simplify this ratio to 1/2, and in its decimal form is 0.5. What is the probability that the card you draw is a diamond? Well, again, how many diamonds in a deck? 13 out of 52, which simplifies to 1/4, which is 0.25. What is the probability that the card you draw is a face card? How many face cards are there in a deck? Well, there are 12 face cards in a deck out of 52. And you can simplify that by taking a 4 out of each one. This will be 3/13, which in its decimal form, let me get my calculator here, 3 divided by 13 gives us, and we have to round off a little bit, so this will be approximate, 0.2307, and it goes on, but depending how many decimal places they want you to write, be careful of that, because they will count it wrong if you put too few or too many. And for this last one, D, the probability of drawing a red spade, well, there are no red spades in a deck, so that would be 0 out of 52, so that would be 0. So remember, probability could be 0 if that event could not occur, and it's usually some fraction in between, and then the greatest amount is if it occurred all the time. That would be 1. All right. Now let's take a look at what the book is offering for these. So they go through it in some detail. You can pause if you want to read it. There's number or letter A, letter B, letter C now for face cards. And notice they are carrying it on beyond 4 decimal places. And letter D. Okay, we're going to take a look now at something a little more challenging. Suppose you grab a snack from a bag of chocolates that contain 4 caramel with milk chocolate, 4 peppermint with white chocolate, a lot of chocolate here, 6 dark chocolate with mint, and 2 raspberries with dark chocolate. Now, what is the probability that you randomly grab a raspberry with dark chocolate for your snack? So as you do this, you have to determine what is your sample space. Well, your sample space will be the sum of all your possibilities. So it'll be 4 plus 4, this 4, this 4, and then plus 6, plus 2. This is your sample space. Now, what event are you looking for? You're looking for raspberry with dark chocolate. How many of those? 2. So now you summarize. Now normally you would do this ahead of time. So this is going to be 2 over 16. 8 and 8 are 16. And we know we can simplify this to 1/8. And its decimal form. I'm not too sure. I think it's 125, but let's see. We define our sample space. 2 are the outcomes we are looking for. Yeah, what a good memory here. Now again, classic probability is rather easy, and we're starting off easy. And as long as you know the basic rules, you shouldn't run into problems. Now, we also have what is called empirical probability. What is this? Well, here, your results, your sample field, is based on an experimental probability. That is, how many trials did you do? That's your sample field, because you don't know what the results could be ahead of time. What we've been talking about so far is what we call hypothetical or mathematical probability, where a coin has 2 sides. A dice has 6 sides, and we're thinking the randomness of it gives us the honesty of a non-weighted coin or a non-loaded dice, if you've heard, where there's trickery involved. Now the formula is basically the same. Your sample field is the total number of times the experiment is performed, and then what event are you looking for out of that total? But here you don't have 6 choices. You don't know that. Your choices are from how many experiments you did and the results you got. And again, this would also be between 0 and 1. All right, let's take a look at example 4. For her elementary school science fair project, Libby is conducting research on the accuracy of weather prediction from her local news channel. She recorded the forecast and the actual weather for 2 weeks. So 2 weeks, 7 days a week, there are going to be 14 events, and the following table shows her results. And if you're taking any science course, you realize this is the tie-in with science. You have your empirical experiment, you have your data, and then what are your conclusions based on the data, and depending what you're looking for. So let's pause and study this for a few moments. So it's kind of easy to check to see where the prediction was correct. And what I did is I put a little red mark after these. And I have 1, 2, 3, 4, 5, 6, 7, 8 times they were correct out of 14 predictions. There's our sample space, 14, and the number of times it was correct, we said, was 8. 8 out of 14 reduces to 4 out of 7, and they're giving it to 1, 2, 3, 4, 5, 6. So that may be what Math Lab is looking for, our software. And we can round it off to about 57% of the time. So that was interesting for a student in the elementary school to do something like this and to kind of get a handle on what probability and prediction is like in the use of math. All right, let's go on to another example. Example 5. Determine the scenarios given are examples of classical or empirical probability. All right. Katie is curious about her chances of winning an e-reader from a student government association. She polled her friends to find out how many of them filled out the survey to be entered in the contest. So this is an experiment, and her sample space is based on the number of students interviewed. So A would be empirical. Hopefully you'll agree with that. All right, Tristan is interested in his chances of winning at the blackjack table. He determines the probability of what his next card will be by knowing the cards that have already been played. Well, here we're using a classical deck of cards, a standard deck of cards, and he's seen what's resulting so far, and he can, if he has a good mathematical mind, can figure out his odds. So this one would be classical, because there's a standard deck of cards. Okay, let's see what they say. Oh, one more. Based on the recent United States Census, a local government estimates the amount of growth the community will experience in the coming year. Again, this was based on collected data, so C would be empirical. You said that, you're on the right track here. Let's check it out here. Okay, A is empirical. B is classical. Very good. And C would be empirical. Okay, this will complete our basic study. You have your homework. We'll have our quiz. And good luck. One more lesson to go.